Assalamualaikum all of you. Welcome to one more session for the logic gates. Now today we are going to study that what are the types of the questions that comes for the logic gates and how we're going to solve them. So as you might see on your screen, that's 221011 is the variant, May June is the session, and 15 is the year. So it's question number 3 in your paper over there in 2015, and the part A says complete the truth table for the following logic circuit. Now you have been provided with a logic circuit that is having multiple of the gates. Now what are the gates? The first gate that is implemented over here is XOR gate. It's an OR gate. It's a NOT gate. And finally again it's a XOR. Now what I need to do, I need to complete the truth table. Now how the truth table is actually given to you guys. So it is given in this particular manner. Now the inputs were A, B, C and the output was X. You finally need to find out the X, and you are provided with a working space that this is the working space, and you need to do a working so that you can get an answer if the inputs are 0, 0 and 0. So at this combination, what will be the output value for the X? For 001, what will be the output value of X? For 010, what will be the output value of X? For 011, what will be the output value of X? Now for this thing, how are we going to do this part? Do remember that the name of the gates are not mentioned. This is for your ease that I have mentioned over here, or for your ease you can mention the name of the gates with the rough pencil or something like that. You can do that, okay? Now the inputs were A, B and C and the output was X. Now what is the first thing that we need to do? We need to name each of the gate apart from the variables that have been utilized over here. So the variables that are utilized over here are A, B, C and X. So from the 26 characters, apart from these 4 characters, you may utilize any of the 22 characters. So for this, for example, I am mentioning this with the name of the P, as it is the reverse of the C. So we do represent a reverse sign by a bar. So I am placing it with the name of the C bar. This could be R, and then finally we do have an X. So for the truth table, how are we going to do that? We are given with the tables we are given with the columns A, B and C. Now what are the 3 other columns that we need to create? We need to check out that what are the name of the gates that we do have mentioned. So we do have mentioned with the name of the P, R and C bar. So in the working space, we need to make 3 more columns that with the name of C bar, P and R. And finally, we will be getting an X over there. Okay, now C bar is actually the reverse of the gate C. C bar is actually the reverse of C right now. So what are the values for C? The first value for the C is 0. So for this, we will be getting 1. Now for 1, it will be a 0 because it's a NOT gate. So NOT gate takes whatever the value it is going to take as an input, it will be giving a revert value out of it. So for 0, it will be a 1. For 1, it will be a 0. For 0, it will be a 1. For 1, it will be a 0. Then again a 1, again a 0, 1, and then finally it's a 0. Now for your ease, you can draw a line as well, but if you're not drawing it, so that's not an issue as well. So for my ease, I have drawn a line as well, and I have drawn the column as well. Now for looking up for the P, so P is actually a XOR gate between A, one of the input for the XOR is coming from A, and the other input, this one, and the other input is coming from B right over here. So we need to check it out with the A and B to check out the output P. Now how are we going to do that? Okay, now the first value for A and B is 0, 0. Okay, now the XOR gate says that output will be high if the inputs are dissimilar. Output is going to be high if inputs are dissimilar. So 0, 0, both of the inputs are similar, so we will be getting 0 as an answer. Again, it's a 0, 0, so we will be getting 0 as an answer. Now it's a 0 and a 1, so we will be getting, as they are both different from each other, they are dissimilar, so we will be getting 1 as an answer. Then a 0 and a 1, so it will be 1 as an answer once again. 1 and a 0, again they are dissimilar, so 1 as an answer. 1, 0, it will be 1 once again. Now it's 1 1, so both of the inputs are similar, so it will be a 0, and again it's 1 1, so we will be getting as answer as a 0 right over here. Now moving ahead towards R. So what was the R right over here? R is something B, one of the input of the R is coming from B, and the other one is coming from C naught. Do remember the other one is coming from C naught. So for finding out the R, we need to check out for the B and we need to check out for the C naught. We do not need to check out for C. We do not need to check out for the C. Do remember this stuff. You need to check out for the B and you need to check out for the C naught. So R was having a OR gate. Sorry, I forgot the gate. So B and C bar. So OR gate says that output is going to be high if any of the input, and the bonus condition was all of the inputs are 1, so that means it's a 1, otherwise it's a 0. For 0 1, so for the 0 1 it will be a 1 as an answer. For 0 0 it will be a 0. For 1 1 it will be a 1. For 1 0 it will be a 1. For 0 1 it will be a 1. I think so, I made a mistake, just let me check. 0 1 it will be a 1. For 0 0 it's a 0. For 1 1 it's a 1. For 1 0 it's a 1. For 0 1 it's a 1. For 0 0 it's a 0 this time. For 1 1 it's a 1. And for 1 0 it's a 1 once again. So this is how you did that part. So this is how you are gonna do this part, or you did that part. Okay. Now finding out or coming towards X. So what is X, or how do you find it? So X is an output, and X is actually a XOR gate between a P and a R. So a XOR gate between a P and a R. How are you going to find it out? So now for this one, you need to check out for the P, you need to check out for the R. So for 0 1, what is the value that you will be getting? For 0 1, okay, the XOR gate says output will be 1, output will be high, output will be on if the inputs are dissimilar. So for 0 1, it will be a 1. For 0 1, it will be a 1. Okay, I don't know why it doesn't support a green color. Let me do it with a different shade for you guys. Okay, now this one could be fine. So for 0 1 it will be a 1. For 0 0, if the inputs are similar, so it will be a 0. For 1 1, again it will be a 0 because the inputs are similar. For 1 1, again a 0. For 1 1, again a 0. For 1 0 it will be a 1. For 0 1 it will be a 1. And for 0 1 again it will be a 1. So this was for the 4 marks, and once you are going to find out the complete answer, you will be getting 4 out of 4. Okay, now how the marking criteria is done for the logic gates? Do remember one thing. For the first pair, do remember I'm utilizing the word pair. So the first pair you will be getting 1 mark. Then for the second pair you will be getting 1 mark once again. Then you will be getting 1 mark for this one. And 1 mark for this one once again. Now just suppose that your first one is wrong and the fourth one is wrong. Let me do it with this one. Okay, first one is wrong and the fourth one is wrong, and middle of the two are right. So will you be getting any marks? No, you won't be getting any marks. Just the reason is that you will be getting a 1 mark for the pair. So you need to have the outputs correct in the pair format. If the first one is wrong, second one is right, third one is right, and the fourth one is wrong, so you won't be getting any sort of the marks against it. Okay, so that was the question for the truth table. Now we are coming to the next question. What does the next question says? Okay, now it says draw logic circuit. Now I need to draw a circuit. In the previous question I was given with a circuit and I need to draw the truth table, or I need to complete the truth table out of it. Now I need to draw the logic circuit. So how I'm going to do that? Draw a logic circuit which corresponds to the following logic statements. Okay, now what is the logic statement? As I told you in the previous video that the Boolean statements are not the part of the course outline. Logic statements are still the part of the course outline. So it do says A is not 1 or B is 1. Okay, do remember, if you can see over here, there are two brackets given over here before A. So this bracket till B is not 1, this is one part. The other part is this one, and it is ending with C. So this is the second part, and the third part is this one. So first of all, you will be going with the innermost, that is A is not 1 or B is 1. Do remember, I told you in the previous video that we do consider that by default each and every input is on 1. So if they are saying A is not 1, that means A is a 0. So by default every input is on 1. So if I need to convert that 1 into a 0, so what I'm going to do, I'm going to place up a NOT gate over that. So it is, first of all, let's see how we're going to do that. A is not 1. It is going to OR with B. Now just after that output, so we are done from here till here. Now it says AND with C is 1. So we need to have an AND gate right over here. Now just after that, what is the other? Now this was the first statement. The other statement is this one. Now it says B is not 1 and C is 1. So this was the B. I am placing up a dot over here. That dot actually says that I have connected one more wire into that. These lines are basically termed as the wires over here. So B is not 1. Now do remember, what is this curve? This curve is actually known as the jump. What it is known as? It is known as the jump. Now this jump means that I have jumped first wire from the other wire. If I'm going to draw it in a like you may say simple line, that means both of the wires are interconnected with each other. So right now both of the wires are not connected with each other, so we made a jump over here. So they are saying B is not 1 and C is 1. So this was for C. B is not 1 and C is 1. Now both of the conditions are connected together with a OR gate. What are they connected with? With an OR gate. So this is how you are gonna draw that part. So this is how you are gonna do this question. Actually, you draw the circuit against this thing. Now moving ahead to the next question. So we did with two types. We completed with the truth table. Then just after that, we made our logic circuit with the logical expression. Now they are saying write a logic statement. Now this time the circuit is given to you. You need to write the logical expression. That's just the reverse of the previous one. Previously you were given with the logic statement and you were asked to draw the logic circuit against it. Now but this time the logic circuit is given to you and you are asked to make a statement against it. Now they are saying what is X. So X is an output, so we do write in this pattern if X equals to 1. Now what do I mean by that? As I told you that all of the inputs by default are 1, so we do say that output is also 1 if this condition is fulfilled. So if X equals to 1, now we will be seeing that what is the first major gate that is being implemented. So this is the first major gate that is being implemented, and first input is coming from the A and the other input for this OR gate is coming from the B. So we are going to write it down in this particular manner. If X equals to 1, A or we are utilizing OR gate. Yeah, we are utilizing OR gate. A or B. This is one of the statement that's been completed. Okay, now in this case we reached over here at this place. We are done with this part. Now we can see that this output is going into the last gate. That's an AND gate right over here. So we will be writing right over here AND. Now what is the other statement for the AND, or where is the other input of the AND? So the other input of the AND is coming from this OR gate, from this OR gate. Now we need to find out actually that where are the inputs for this OR gate coming from. So right now they are coming from, one is coming from B, you can see over here, one is coming from B and the other one is coming from C. No, it's not coming from C, it's coming from C naught. It's coming from C naught. So we are going to write it down in this particular manner. B, then we do have a OR, B OR, and then we do have C, but it's a NOT gate, so we'll be writing C not 1, C not 1. So both of the inputs are of the AND gate, both of the inputs are written. First one is coming from the OR, so we write the equation for the OR, and the other one is coming from the again OR, so we write the other one for the OR as well. So one statement is this one statement is the other one. We place the bracket on both of them. So 3 marks were given for this one. Okay, now we do have one more question. So we did 3 types of the questions right now. The first question was regarding the truth table. The other question was regarding something like you were asked to draw the circuit against it. Now the third question was something that you were given with the circuit and you need to write the logic statement out of it. Now for the the fourth question, they do say that you are given with a statement once again and you need to draw the circuit, but this time the statement is given in a scenario based format. So how they have given us, they do say a gas fire has a safety circuit made up of logic gates. It generates an alarm x equal to 1 in a certain condition. What are those conditions? Or in a certain fault condition, it's written over there. Input is given over here, description is given over here, binary values and the conditions. So for the input, they are saying we do have 3 inputs over here. It's G, C and L. G represents the gas pressure, C carbon monoxide, L represents the gas leak detection. Now G is having 2 values, 1 and 0. At what condition the value of G will be 1? If the gas pressure is correct. At what condition the value of G will be 0? If the gas pressure is too high. Similarly for carbon monoxide, if the carbon monoxide level is correct, so it will be a 1. Otherwise, if it's too high, so it will be a 0. For gas leak detection, no gas leak detected is 1, and if there is a gas leakage, so we do have a 0 right over here. So we are given with the conditions right over here. Now, what is the statement that we need to follow? We need to follow, it says the output x equals to 1 is generated under the following conditions. Gas pressure is correct, and now this AND written in the capital in the block letter is actually representing the AND gate. It do represents the AND gate right over here. So it says gas pressure is correct and carbon monoxide is too high. Gas pressure is correct and carbon monoxide is too high. So how are we going to do that thing? We are given with the logic circuit statement that where we need to draw it. We are given with G, C and L. So first of all, they are saying gas pressure is correct. So gas pressure is represented by G, and if it's correct, so the value of the G should be 1. So the value of the G should be 1 right over here. Okay. And so the first input of the AND will be coming from G and it will be 1. Other one is coming from carbon monoxide is too high. So for carbon monoxide too high, the value of C will be 0. That means I need to place up a NOT gate over a C. So how I'm going to do that? And C, I need to place up a NOT gate. So it was a AND gate applied over here. Do remember, you need to make the circuits properly, or you need to draw the symbols properly, because you are awarded with the marks against these symbols. Okay, so we did with the first part. Gas pressure is correct, that means G, and it's going into the AND, whereas carbon monoxide is too high, so for too high it was a 0. Now it's going into the other gate that is known as the OR gate. It is going into the OR gate, so that means we do have an OR gate right over here. We do have an OR gate. Now what will be the other input for the OR? So for the other input of the OR, it do says carbon monoxide is correct. That means this time C is 1. Again an AND gate is being applied and the gas leak is detected. That means L will be 0. So C will be 1, AND gate, and L will be 0. So C will be 1, AND gate and L will be 0. Going into the OR gate finally. So this is how you need to draw this circuit. Then again the truth table has been asked for you. So multiple of the times the truth table has been asked from you to you are asked to make to complete the truth table and all. Okay, now there is one more question that is remaining. The type of the question that is remaining. That's quite an interesting one. Okay, let's assume this one. Now it says complete the truth table for the following logic circuit, which is made up of NOR gates only. Now there are only the NOR gates that have been implemented. Now the two inputs are given. Now if you can see with the first NOR gate, so you will be seeing that the input was coming from A and then it has been bifabricated into two different paths. That means the first input was a 0. Now the 0 was coming from here, right over here. Now if it is bifabricated, so what is going to happen? So just let's take an assumption. A water stream is being flowing. There is a land piece in between and now the water started to bifabricate. So if it's bifabricate, so obviously on both of the sides the same similar water is going to flow. Similarly, if A was giving a 0 and the passage is bifabricated into two different parts, so on both of the paths the similar value will be going as a 0. So how we are going to do this one? First of all, we need to name the gates. So we can just say that it's P, Q, R, and finally we do have an X. So for for P, we need to do it over here as well. P, Q, R, and X. So P is having first input of the A, that is a 0. So if 0 was coming from here, so over here it will be a 0 again and it will be a 0 over here once again. So for 0, 0, for the NOR gate, we do say it's a 1. Again for 0, 0, it's a 1. For 1, 1, it's a 0. And for 1, 1, again, it's a 0. Now coming towards the Q. Q is for the B. It says the first input is 0. So for 0, 0, it will be a 1. For 1, 1, it's a 0. For 0, 0, it's a 1. And for 1, 1, it's a 0 once again. Coming to the R. Now R says the R is having the two inputs from P and Q. So P and Q, 1, 1 will be a 0. 1, 0, 0. 0, 1, 0. 1, 0, 0, it will be a 1. 0, 0, it will be a 1. Now coming towards the X, so again the similar stuff is happening. 0 is the first input. Now the 0 is going from here and it's now bifabricated in two paths. So obviously on both paths 0 will be going. So for 0, 0, we will be getting an output of, do remember it's a 1. For 0, 0, it will be a 1. Again for 0, 0, it's a 1. Then 0, 0, it's a 1. And for 1, 1, it's a 0. For 1, 1, it's a 0. This is how you need to do this question. Okay. Now what they are asking further on, in the second part, they do say, the question says actually, just a second. What single logic gate has the same function as the above circuit? Now actually what they need to say, they are saying if you are having the inputs A and B and the inputs were 0, 0, 0, 1, 1, 0, 1, 1 and you are getting the answer as 1, 1, 0. So what single logic gate will be giving you this answer if you are having this set of the input? If you are having this set of the input, so what single gate will be what single thing will be giving you, or what single gate will be giving you this answer? So let's see with the Boolean logics, what was that? Okay, now the AND gate was something that output is going to be high if all of the inputs are high. So only one, it was one at one condition. For NAND gate, it says output will be low if both or all of the inputs are high. So if you can see with this thing, only at 1, 1 we do have a 0. Other than that, we do have the ones over here, just like in the NAND gate truth table. So over here, the NAND gate is the gate that can have the similar answer as of the complete logic circuit that we have just got an answer from. So the answer will be NAND over here. So these are the types of the questions that you are going to witness when you are going to solve your logic gates question. So see you in the next class. Thank you so much, guys. Allah Hafiz.